Hope you're doing great. Welcome to my channel, The Consistent Coder. So the problem we are doing today is maximum depth of a binary tree. So given the root of a binary tree, we have to return its maximum depth. So how is the maximum depth defined here? It is the number of nodes along the longest path from the root node down to the farthest leaf node. So let's take an example to explain what is he saying. So he's saying that from the root node to the leaf node, if you travel down, whichever path has the maximum number of nodes, that will be the maximum depth of this binary tree. So here the leaf nodes are 9, 15 and then 3. What are leaf nodes? Leaf nodes are those nodes which doesn't have any left child or right child, correct? So here you started from 3 and then you go to 9. So the number of nodes you encountered is 2. Why? The only nodes are 3 node and then 9 node. So 2 nodes. But there is one more path. So 3 and then 20 and then 15. So here the number of nodes, if you travel this path, the number of nodes you will have is 3, correct? So you have 3. And then there is one more path, that is 3, 20 and then 7 and then 3, correct? That is one more path. And how many nodes did you encounter in this path? 3, 27, 3. So that will be 4. So the maximum of this is what the answer is. Like max of this is 4, correct? And so the depth of this particular binary tree is 4. That is the problem. We have to find the maximum depth accordingly, right? Okay, now what are the initial thoughts, like how can we solve this problem? So most of the binary problems, they can be solved with recursion, right? If we try to understand properly how exactly it works for one particular binary problem, then you can probably generalize it and then solve most of the binary problems, binary tree problems very easily. Okay, let's try to understand it. Here we are traveling all the way from root node to the leaf node, right? So if suppose I reach a point, like if I travel from root to leaf node, I understand that if suppose I reach a leaf node, there is no more nodes further than that node that I could travel to. What I'm saying is, if suppose I reach the node 3 while I'm this particular leaf node 3, while I'm traveling in the binary tree, there is no more further nodes, right? So I cannot travel any further. So what I'll do is I'll return 1. Why am I returning 1? I'll return to 1 to the previous node. Why? Because there are no more nodes, no left child, no right child. And the only node is this particular node 3, correct? And remember, when we are calculating the depth, we have to consider the number of nodes, because that is what the problem is asking, right? We have to calculate the total number of nodes and we have to return him the maximum number of nodes along the path, whatever is the maximum. Okay, so I'll return 1 in this case. So what this 7 will do? Now 7, it doesn't have any right child, right? So what it will do is it will say the maximum. Now it has a decision to make. Now if it travels to the right side of it, there are no childs, correct? The number of nodes that it could gain if it travel to the right side is basically 0. Why? Because there is no node, there is no path, it cannot travel anything. Now if I ask what is the maximum number of nodes that it could gain traveling right side, it will be 0. Okay, now what it will obviously do, it will try to maximize the number of nodes that it could travel, right? Because that is what the problem is asking. So I'll try to travel to the left side of the tree, right? If I ever come to 7, I'll make a decision that I'll travel to the left. Okay, because there is one node which is greater than the 0 node. So what I'll do is I'll travel this way. But if I travel this way, how many nodes did I just increase myself with? 1 plus 1. Why? Because if I travel from 7, that means I have one node, the 7 node. But I know from the left side I already have one node, right? Because I just returned 1. So that will be 2. So I have 2 nodes if I started traveling from 7. Right, now I'll return this value to 20. Okay, now I return 2. Now this is a leaf node, so I'll return 1. Now again I have a decision to make, right, at the node 20. If I travel to the left, how many nodes can I maximum travel to? One node, plus one more node, which is the 20th node itself and the 15th node. Okay, that will be 2, correct? But if I travel to the right, I have 20 node itself and then 2 more nodes, right? Because I just got the value saying that I have 2 more nodes to the right side of it. So obviously I'll try to travel to the right side because I want to maximize my number of nodes that I'm going to travel with. So if I travel to the right side, how many nodes will I have? 1 plus 2, correct? So that will be 3. Now I'll return 3 here. Okay, and now since it's only a leaf node, I'll return 1. Now again I have a decision to make at root node 3. Now I can travel to the left side where there is only one node, or I can travel to the right side where there are 3 nodes apart from the root node, right? Now what will be the maximum value here? So if I do this 1 plus 1, which will be 2 nodes if I travel to the left side, or it will be 1 plus 3. Why? Because I already have 3 nodes to the right. So 2 comma 4, what is the maximum of those? Obviously 4. Okay, and that is actually the answer as well, right? If you remember, previously we tried to do it, and then we got the answer 4. So I hope this is clear to you what is happening here. Let's try to code it up. So what we have is here you can actually write your own recursive function, or you can use the function that he has already given. So what are we trying to do? If there is, first what did we do? We identified whether if we reached a node which doesn't have any left child or right child, right? Correct. So if my root has no left and it has no right, so in that case what am I doing? I'm just returning 1. Okay, otherwise what am I doing? I'm trying to calculate the depth, maximum depth. So see here, the function that I'm using is the recursive function, because every time assuming that whatever the node is, that is my root node, right? Every time I'm assuming that, because every time I'm trying to calculate from the bottom what are the maximum number of nodes that I could actually give it to the parent, and from parent I'm making a decision, and then I'm moving forward from there. So here I'm calling my recursive function and then root dot left, and then I'll also call my right child, and then I'll ask what is the maximum depth that you could offer me, and then I'll simply calculate the maximum of this. So when I calculate the maximum of this, I'll get the maximum value. So for example, here if you see, here I got 1 node, here I got 2 nodes. So what am I doing? I'm trying to calculate the maximum of 1 comma 2, correct? And then what do I need to do? I just need to do plus 1. Why? Because this particular node, whenever I reach here, I need to return plus 1, because this node itself is also one more node, right? So apart from the child nodes that I'm getting, I'll have to add plus 1 so that I'll return the value. But remember, there was a case like in this particular example, when we are here, there is no right child to this particular node. In this case, what will happen if we try to do this? There will be root dot left, but there will be no root dot right. So we have to handle that case as well. So if my root is actually null, I'll simply return 0. Okay. So otherwise, if it has no left and no right, I'll return 1. Otherwise, I'll first find what is the depth of the left child and what will be the depth of the right child, and then I'll take the maximum of it and then I'll return it. And that's it. It should work. So yeah, the test cases are working fine. Let's try to submit it. Yeah, as you can see, it's working fine. So yeah, that's it for the video, guys. Hope you liked it. If you did, please do give a like, and please consider subscribing, because I'll be uploading my videos consistently on a weekly basis. And stay consistent. Bye.